Actually, I chose my background because it looks like the map. He's left, so it doesn't matter. This is shedding light on dark matter. I teach at West Virginia University, Parkersburg. This is somewhat more theoretical. Okay, you don't need the abstract. Basic. There. Okay, basically there's a problem. Another problem, other than the one he just went over. When we view galaxies, we note that as you go out from the core of the galaxy, you have faster speeds close to the core of the galaxy, then the speeds level out. You have constant speed out to the rim of the galaxy, the edge of the rim of the galaxy. According to gravity theory, that's not possible. This is called the galactic curvature. The existence, and they've assumed the existence of a cold dark matter halo surrounding the galaxies to equal that out, to account for the constant speeds. Then they have no idea what the cold dark matter is. Also, they talk about hot dark matter and dark energy, not knowing what they are. They are assumed. They can somehow detect them, but they don't know what they are. Okay, this is Andromeda galaxy, and you can see as you're going radial distance in light years, 10 to the third against the rotational speed. Here's the speed at the core, and it slims out. But according to just Newtonian gravity theory, the speed should fall off exponentially as you go out towards the rim. Big problem. And I understand from our astronomer that even some other galaxies now, it's almost straight out from the galactic core. And they can't account for these constant speeds. Also, we have other problems. There's only enough normal matter to account for 20% of the amount necessary to collapse the universe in the Friedmann-Lemaitre model of the Big Bang. The solution for that is they assume dark matter is composing approximately 80% of the universe. Large dark matter can be actually dim matter, can be large bodies such as giant planets, brown dwarfs, and other unseen stars like black holes, large clouds of non-luminous gas, supplying the extra gravity to collapse the universe. So it's a dual problem, not only the galactic rotation problem, but collapsing the universe. There's just not enough matter. And some of these forms of dim matter are called machos, and they believe they inhabit the dark halo to account for that extra gravitational. Or when the gravitational effect is observed, it cannot be associated with normal dark or dim matter of any kind, then this is what they call dark matter, or the two forms. Now there are also quantum solutions to this problem. The quantum people invent a particle for everything. If you can't explain it, invent a particle for it. I'm sort of semi-anti-quantum theory. So they invent hypothetical particles called WIMPs, axions, supersymmetry particles, and other hypothetical non-baryonic particles to explain machos. Machos are the particles, the matter they believe is in the halo. Massive halo objects. There's a third type of solution to solve this galactic rotation problem. I just found out about this for 2 months. That's the whole purpose of this talk. And it's called MOdified Newtonian Dynamics, developed by Milgram in 1981. That's changed Newton's second law of motion. It's no longer F equals ma. You've got a fudge factor, mu of x, which depends on distance. Literally a fudge factor. I find that aesthetically displeasing, so that's what got me interested in this problem. Okay. Now there is a simple solution, very simple. Assume space, physical space, is four-dimensional, not space-time. Fourth dimension of space means a fifth dimension for space-time. Matter equates to real curvature in the higher spatial dimension. This means that space-time, as described in general relativity, is five-dimensional. In other words, space-time curvature is extrinsic to our four-dimensional space-time, whereas it's normally considered intrinsic in general relativity. We already have a theory of this called Kaluza's theory, developed in 1921, used a five-dimensional mathematical model to unify gravity and electromagnetism. This model that I'm proposing is perfectly compatible with all the physical laws of nature and is falsifiable. Okay, try that. Okay, basically, if we have a real curvature, this would be our universe, the Riemannian sphere, three-dimensional surface, curved in four-dimensional space, and this is the Einstein radius. You have a galaxy. Galaxy is also a three-dimensional object, so normally we would see the galaxy conforming to the curve of space, but actually galaxies are big enough, they actually stick out like this. Now what happens then, space-time curvature has to pull up to meet the rim. I call that a shadow or mirror curvature. But in reality, what we see, we're three-dimensional objects. We are in this surface, in a sense. So when we see a galaxy, we're looking through 3 dimensions, and what we see is the galaxy here, not up there where it really is. And then that creates this halo effect. If you look at the actual curvature, I tried to sort of hand draw what a curvature would look for a galaxy. This is your normal 3-dimensional space curved to 4 dimensions. You've got a galactic core here, which would affect the speeds. This would be a central object, probably a black hole or something. Here's the halo out here. And then here is the rim. The rim would look like this, and that's a measuring curvature, so that's constant potential, which means that would be constant speed, because equal distance from the normal curvature of the galaxy. If you take a look at the Andromeda graph that I showed a minute ago, you've got the actual graph showing the speeds. This is according to Newton's law. You should have the exponential curve. Now the only way to get this constant speed is to have the halo out here, which I call mirror or shadow curvature, and you add these 2 speeds together to get constant speed here. Now, all this can be broken down and explained. Nice thing about it, I like things simple. I believe philosophically that nature, in the end, is very simple. We complicate it with a lot of mathematics. I'm old school. So, you can explain this curvature with simple geometry. Basically, you've got the Einstein radius, you've got the center of curvature for your galaxy, Einstein radius, and you've got distance x above here. Now you can just take the Einstein radius, calculate the height of this curvature, using Pythagorean theorem. Very simple. Einstein radius is 10 to the 10th billion light years, whereas the rim of the galaxy, the rim of the galaxy here is about 10 to the 5th light years. So this distance would be very small, but given the curvature of the center part of the galaxy, you can show that the curvature for the halo is approximately equal to the curvature of the galaxy. I don't have these figures. I've only been working on this about a month, so I haven't done a lot of calculations yet. But using a simple geometry, you can show the speed is constant. But the thing is, you have to assume a real fourth dimension space. Now, that allows me to define dark matter. The rest of the curvature here then would be what we call hot dark matter. So this model explains both cold and hot dark matter. Now, cold and hot dark matter are space-time curvature that is not associated with local matter. Dark matter is therefore a curvature that can only be associated with the global or total material content of the universe. Dark energy is actually then an energy potential that rises from a small or minimum thickness of our 4-dimensional space-time in the 5th spatial direction. I can't see it. Is that done?
No, you got a couple of minutes.
Okay, I went through this really, really fast. Now, implications. Modified nuclear dynamics is out. We don't need to modify F equals ma to show the constant speed, although we do have to accept a fourth dimension, physical fourth dimension to our normal space, which is even more radical. But I don't believe we should modify F equals ma because this is basically a gravitational problem. It is not a Newton's second law problem. Superstrings out. Oh, sorry, if anyone out there is a superstring person, I don't like superstrings. Superstrings are out because they assume higher dimensions. But the higher dimension superstring theory are compactified. They're only at the Planck length. I'm talking about a macroscopically extended fourth dimension. Only 5-dimensional space is needed for total unification. In other words, you can unify relativity and quantum theory and actually show what all the natural forces, 4 natural forces or interactions are in a 5-dimensional theory. You don't need 6, 7, 8, 9, 10, 11, or 26 dimensions like in superstring theory. This leads to Einstein-Kaluza 5-dimensional model of spacetime as best possible theoretical model that corresponds to the solution of the galactic rotation problem, and you can unify all of physics based on that model. Einstein worked in this model. He wrote papers on it in 1938 with Peter Bergman, and in 1949 with Peter Bergman and Valentin Barton. Questions? Silence.
Well, you don't really show that, you have a unification of gravity
No,
and quantum,
that's
right?
implication. I can stand up here and I can give you a complete five-dimensional model of the atom if I had another half hour, where I can unify the fluid drop model, a shell model, into a single model of the nucleus, and show the Yukawa potential, and also the Bohr electronic, all in a single five-dimensional model. Right now, for purposes of this talk, it's just an implication.
Any further questions?
Yes?
Would there be other evidence that a fourth spatial dimension exists in some
Yes,
other areas?
actually, I'm right now the paper in publication. It's been accepted provisionally. I have to make a few small changes in it. 3 logical proofs of the existence of fourth dimension. You do electromagnetic theory. You study del cross B is equal to A, where A is the magnetic potential. You do del dot A is equal to 0. That is only possible. You're taking a derivative in 3-dimensional space simultaneously when you do del cross B is equal to A. It's not A sine theta, like in normal cross products. Now that implies that magnetic potential is in the fourth direction of space. No one knows if you read through all the literature with most advanced physics, you get electrical potential, which is volts. There is no such thing as magnetic potential, other than the mathematical quantity. We can't measure magnetic potential, magnetic volts. We can't measure them because they're in that fourth direction. But they are there mathematically, and the cross and dot product show that is at 90 degrees to our normal 3-dimensional space. That particular theory dates back to the 1870s with William King Clifford. He tried to do a theory of magnetic induction in 4-dimensional space. So this has a history to it also. That's one of my 3 proofs. Other questions?
All right. Thank you, Dr. Beckler.